everyone, today we are going to solve the problem elevator rights. This is the 17th video from the DT series. So there are n people who want to get to the top of a building, which is only one elevator. You know the weight of each person and the maximum allowed weight in the elevator. What is the minimum number of elevator rights? How do you tell that? Let's first try to understand it with example. You have four people and the weight, the maximum allowed weight is 10, and the weight of the each person is 4, 8, 6, 1. Now let's try to do it. Uh, what would be the brute force? That is, you process the papers in this order. Let's try to find for this order. You have to make one write for 4, you have to make one write, another write for 8, because you cannot make a write simultaneously for the people 8 or 4, because the weight of these two peoples are uh, the weight of these two peoples is 12 and the maximal output is 10. So you have to make two writes, right? For this one, another. For this one, you have to make another write, right? But wait, you can process these two peoples in one write. So the number of write that you have to do is 3 if the people are in this order. Now let's try to change the order. Let's say 4, 6, 8, 1. So you could process these two people uh, simultaneously, and you can make a write for these two people, uh, right? So this requires only two writes. So the minimum number of write that you could have, that is 2, right? That you have to do is 2. So the brute force approach would be try out all possible ordering, try all possible ordering, all possible ordering, and find out the minimum, and find out the minimum one. This requires n cross n factorial. The time complexity of this approach would be n cross n factorial, which is very much slow for n lesser than equal to 20. So you have to optimize it. So how could you do that? So to optimize it, let's first try to make an observation. That is, let's first process these three peoples, right? So for 8, 6, the number of orderings could be 3 factorial, that is 6. So these are the possible orderings, right? So for this, you have to find out the number of writes. So for this, you have to make 3 writes, right? And one thing, one more thing that you have to trace, that is the last weight, and this is the number of writes. So in this case, last weight is 6. So last weight is 6. And for this, the number of writes would be 2. The last weight is 8, because you can process these two people simultaneously, and you have to make another write for 8. For this, you have to make two writes. The last weight would be 6, 6 for 10, right? Now for this, you have to make two writes. The last weight is 10. You have to make three writes. The last weight is 4. You have to make two writes. The last weight is 8, right? Perfect. Now you have to find out the number of writes. If there is another people whose weight is 1, uh, you have to find out the number of writes. Uh, if there is another people whose weight is 1. So, and the information that you have, that is the number of writes and the last weight. For this, the answer would be, you have to add, this is the last weight, right? So by adding 1, the weight is going to be 7, which is allowed. So the number of writes would be 3, and the last weight is 7. For this 2, 9, in this case, you have to make another write, because the last weight is 10, which is, and if you add 1, this would be 11, which is not allowed. So you have to make another write, and the last weight would be 3, 1. Similarly for this, and for this. So you can find out that uh, these are the two states from which uh, you can make your answer, right? That is true. You can find out your answer. Now by using this observation, what is the observation that could I make? That is, to find out for answer for the next state, you just need two uh, information, that is the number of writes and the last weight. Number of writes and the last weight from the previous state, right? So how many subsets are there? There are 2 raised to the power n subsets. So you have to process only 2 raised to the power n subsets. for the 2 raised to the power n states. So the 10 complexity would be n into 2 raised to the power n, which would be better than the n into n factorial, right? So let's try to find out by using this observation. Find out the answer by using these observations. So we have the number of subsets, that is 2 raised to the power n, 2 raised to the power 4, 16. So there are 16 subsets, right? There are 16 subsets. So there is something we have to maintain, that number of lights and the last weight and the last weight, right? Perfect. So for the empty set, the number of lights would be 1 and the last weight is 0. And for the next state, the next state is yes, the next state is 4. So for this, the number of lights would be 4 and the last weight is 1. Similarly, for all of these, number of lights would be 1 and the last weight is weight is itself. Now let's try to process this one, 4, 8. So if you process 4, the previous state is going to be 8, that is 1, 8. And can you process it? No, you cannot, because if you're going to process it, the weight would be 12, which is not allowed. The allowed weight is only 10. Now you have to take another right and the last weight is 4. Now if you're going to process 8, it depends on the previous state 1, 4. Now can you process it? No. Again, the weight would be 12 and the allowed weight is 10. So you have to take another right and last weight is 8. What would be the optimal among them? The optimal would be 2, 4, because if in future you have to process 5, 6, you can process it 5, 6, 7. No, 7, not 5, 6. So, but in the case of 2, 8, you cannot. You have to take another right, right? So you have the optimal one would be 2, 4. Similarly, in 6, 4, you can process it. If you in 4, 6, if you try to process 4, it depends on the previous state of 6, that is 1, 6, and you can process it because the weight would be 10 and this is allowed. So 110 would be the optimal answer for this. Similarly, for this 1, 5, for this 2, 6, for this the answer would be 1, 9, for this the answer would be 1, 9, and for this the answer would be 1, 7. Right? Perfect. Now let's try to do for the next state. Now let's try to do for the next state, which is this. So if you try to process this state 4, 8, 6, if you try to process 4, it depends on the previous state 8, 6, that is 8, 6, 2, and what is this? It is 2, 6. Right? 2, 6. Can you process it? Yes, you can. And the last weight would update it to 10. If you try to process 8, the previous state would be 4, 6, and if you for this 4, 6, 110, right? 110. So 110. Can you process it? No. 2, 8 would be the next state. If you try to process 6, it depends on the previous state, which is 4, 8, 4, 8, 2, 4, 2, 4. So 2, 4, can you process it? Yes, 2, 10. So what would be the optimal one? 2, 8. 2, 8 would be the optimal. Similarly, in this case, if you try to process 4, it depends on the 6, 1, 6, 1. Can you process it? No. 2, 4 will be the state. And if you try to process 6, it depends on 4, 1. Can you process it? No. 2, 6. If you try to process 1, it depends on 4, 6. 110, no. 2, 1 will be the next state. So the optimal one is 2, 10. In this case, if you try to process 4, 8, 1 will be the previous state, and 1, 9. Can you process? No. 4, 1. Can you process it? No. Because previous weight is 8, 8, 5 is 13, which is larger. So 2, 8. So if you try to process 1, 4, 8 would be the previous one, 2, 5. So among 2, 4, 2, 8, 2, 5, the optimal one is 2, 4. No, right? 2, 4. Now, in the case of this, if you try to process this, it depends on the 6, 1. 6, 1, you cannot process. 2, 8 will be the next state, and 8, 1. 8, 1 is this. You cannot. 2, 6 is the next state, and 1, 8, 6. 8, 6 is this, and 2, 7 will be the next. So the optimal one is 2, 7. Now let's try to process the last state. The last state. If you try to process 4, 8, 6, 1 would be the previous state. 8, 6, 1, which is this one. 2, 7. Can you process it? No, right? You cannot. 1 second. So 3, 2 6 would be the state in this case, right? This is 2 6, right? Why? 2 8, 2 6, 2 7. Among there, 2 6 will be the minimum, right? Perfect. Now this will be 2 6. You can process it. 2 10 would be the answer. In the case of 8, it depends on 4 6 1, which is the previous state. 4 6 1 2 1. Can you process 2 9 2 9? And 4 6 4 8 1 would be the previous state, which is 2 4. You can process it 2 10. And in this case, 4 8 6 would be the process 2 9 would be so among there, 2 9 will be the minimum. And our answer is going to be 2. That is the number of rights, right? So 2 will be our answer, right? Now the main idea is there that our next state answers depend on the previous states, right? And we have to process all these states. This state answer depends on the previous state, right? Previous states and previous states, right? Previous state. So, and I have to process all the 2 raised to the power n states. So to process all these states, I am going to use bit mask, right? So these are the mask that represents all the subsets. So suppose 0 1 1 0 represent the subsets 8 6, right? 1 means it is present in the subset, 0 means it is not. So now let's try to understand how we can do transition. So suppose I have a mask 0 1 1. What it represent? It represent 4 6 1, which is this one. I have to process this state. Now, how can I know that there is some element present or not? I can use the bit is set or not. Like if it is set, so I have to process this state, otherwise not. So to check set or not set, what I can do, mask and one left shift of bit. So suppose this is I have to check this bit is set or not. So what I can do, I can 0 1 left shift and do AND operator. And AND operator, if both are true, it will return true, otherwise it will return 0. So if the number is greater than 0, it means it is set, otherwise it is not, right? So this is how we can check the bit is set or not. If it is set, then I have to do transition, right? The operation, let me write mask and one left shift of bit, right? Now, if I have to do, I have to process this bit. So it means that I am going to take 6, right? And 6 it depends on the previous state for one. So how can I achieve this previous state? So to achieve this previous state, what I can do that I have to toggle it. I have to toggle it. So this is my previous state, right? That is 4 and 1 in the set in the subset. So I have to toggle it. To toggle, what I can do, that is one left shift of bit, and I have to do XOR. If both XOR operation is 0 0 0 0 1 1 and 1 0 1 and 1 1 0. So 1 1 0 0 0 0 1 1. This will return. This will gives you the previous state, right? And then you have to do your transition. That is, uh, if you can process it, then you have to add the weight to the last weight, and if it is not, you have to add the number of bytes and you have to update the weight, right? This is something that we can see in the we will see in the code. So this is how you can use bit mask to process all these states, and you can achieve your answer, right? Now let's try to code it. I hope you understood it. If it is not, you comment it down. I try to resolve your doubts. Now let's see the code.
So let's try to code it. We have n number of peoples and allowed weight is x. Now we have to take the input weights, right? So for int I equals to 0, I guess I is plus weights I, yes, this is the input. Next we have to define the vector pair of int dp of size of 2 raised to the power n, and we have to initialize it with some maximum number such that we are able to update it with minimum. Right? This is our DPI. DP dot first, that is it represents the number of lights, and the second is denoted the last bit, denotes the last bit, right? Now dt of 0 is equals to number of lights 1 and the last bit is 0. This is our base case. Next we have to traverse for all mask equals to 1, mask less than 1 left shift of n, right? Then we have to do mask plus, right? Perfect. Now we have to traverse for all bit equals to 0, bit less than n, and bit plus plus. Now I have to check it is set or not. If mask mask and one left shift of bit, if it is set, then I have to do uh, then I have to process this bit. So what next I have to do that yes, if it is in the limit, right? If it is in the limit, so dp of mask dot let's take the previous state, wait, mask zor, and we have to do one left shift of bit. If dot first, that is the number of dot second plus the weight of that bit is less than equal to x, right? If it is the case, that is if I'm taking the current weight and the previous state, the last weight is this, right? The last weight is this. If last weight plus this weight is in the limit, that is it is allowed, then we have to what we have to do, then we have to update the weight, right? So dp of mask equals to minimum of dp of mask comma dp of mask, let's take the previous state, mask zone one left shift of bit, and dot second plus dot first comma, and this dot second, that is the last weight, right? This is the last weight dot second plus the weight of that bit, right? So this is the transition for if it is allowed, right? If it is not allowed, that what we have to do, then we have to add the number of writes, right? So I just copy this line, right? Then I have to just add the number of writes if it is not allowed, and we have to replace it with the current bit that we have, right? This is the, that is if allowed, right? Or this is for not allowed, right? And finally we have to return our answer, that is cout dp one left shift of n minus 1 dot first, that is the minimum number of lines, right? So this is the code. Let's try to run it. Let me check once if there is any typo mistake or not. I have to do I have to take input, right? Perfect. This also looks fine. Yes, it is set, and this is last word is, let's try to run it. It looks great. There's a mistake. What is this? Twitter pair int comma int. We forgot it. Pair int comma int. Let's try to run it again. Yes, let's try to run it again. Yeah, it gives us right answer. That is 2, right? So this is the code. I hope you got this. The time complexity we discussed it. That is n into 2 raised to power n. Yeah. So if you understood it, comment it down. Understood. If there is any doubt, let me know. I try to resolve it. Fine. Thank you.